Today's site is one of the very popular photovoltaic green roof site in Sydney, Australia. So before I introduce today's case study, I just want to quickly remind you of the characteristic of energy infrastructure. So far, lots of energy infrastructure, lots of renewable energy projects have been initiated and developed around rural area so that the long distance energy transmission lines are inevitably needed to deliver the energy to the urban areas where the energy is actually needed and consumed. Also, although renewable energy is regarded as a promising innovation to reduce carbon emissions by substituting fossil fuel-based energy, renewable energy has been typically criticized for its fluctuating and intermittent energy supply characteristic compared to the fossil fuel plants or nuclear power. And as you can see from the graphs here, renewable energy shows highly fluctuating and intermittent energy generation characteristics compared to the fossil fuel based, which have a very constant rate. And this is because renewable energy is highly dependent on the climate conditions, while the fossil-based energy can be adjusted and managed by our demands and needs. And this kind of difficultness of forecasting energy generation make the electricity grid hard to find a balance between the energy supply and demand, and which ends up making the grid to become very unstable and less resilient. And then for the next, we need to think about the context of an urban areas. Cities are very densely occupied, so it is prone to happen various land use conflict. Although some promising green solutions, green surface solutions like green roof and photovoltaic roof have been discussed over some empty places like a building rooftops or the some fragmented spaces near the transportation infrastructure. But those places are likely to be conflict in terms of the land use. And also, there was a knowledge gap over which of such green surface solution is appropriate and proper in which of spatial context. And since both green roof and photovoltaic roofs are very important and they have unique environmental and social advantage in terms of climate change adaptation and mitigation, these limitations should be addressed as soon as possible. So one approach that we can think about is vertically staking and integrating photovoltaic panels above the vegetated surface. And according to the concept and the theory of the urban metabolism, increasing the efficiency of the energy and matter circulation in an urban area is very crucial to make the city sustainable and resilient. So for example, one of the reasons that we are doing either photovoltaic roof or green roof is to retain more rainwater and to produce energy from the on-site while reducing their artificial import from the outside of the city. So therefore, in order to improve the efficiency of those energy and matter circulation, it is important to think about how we can use land in a very efficient and productive way. And many underutilized spaces, such as parking lots and building rooftop, could provide a kind of untapped potential for improving efficiency by adding an additional energy layer over the existing land uses. So this is today's case study site, photovoltaic green roof project. And sometimes this photovoltaic green roof is called as the biosolar roof. And this was carried out on the rooftop of two adjacent buildings in downtown Sydney, Australia. And then the project was led by Peter Ilga from the University of Technology, Sydney, And this project was funded by the City of Sydney Council with research that is carried out to prove the various environmental effectiveness of photovoltaic green roof. So the team installed solar photovoltaic panel array over an existing green roof of Daramu House building and a typical solar photovoltaic roof of the International House building, respectively. As a kind of comparative study, the research team compared photovoltaic green roof to the typical solar roof in order to reveal the advantage of photovoltaic green roof. They directly measured and collected data that are related to the following 5 factors, like biodiversity, air quality, thermal insulation, stormwater runoff management, and the performance of the photovoltaic roofs. And these are the some of photographs of the sites. As you can see, the images, the photovoltaic panels are installed over the vegetation covers that is consist of low-height shrubs and grasses and sedums, and photovoltaic height is just and slightly higher than the height of the person's knee. So they actually analyzed biodiversity improvement with the Shannon's diversity index by including the number of presence of insect and birds. And this research team observed that the presence of the green roof resulted in a 9-fold increase in insect species and 4-fold increases in avian species diversity. The research team also proved that the photovoltaic green roof is likely to improve the air quality through the field measurement than the typical solar photovoltaic roof. And I highly recommend you to read the original report of this, and you will find more detailed information about this. The research team also investigated the thermal insulation effect of photovoltaic green roof by using thermal camera as well as the temperature sensors, and they actually monitored the vertical temperature profile of 2 roofs. For the result, for temperatures below the solar panels, both the average and maximum daily temperature were significantly lower on the photovoltaic green roof than the conventional solar photovoltaic roof under the similar condition of the solar radiation. However, minimum daily temperature on the photovoltaic green roof were higher than those on the conventional photovoltaic roof. So they concluded that the insulative capacity of the green roof to not only prevent heat transfer indoors, but help retain heat during the colder periods. In general, collocating photovoltaic panels over the green vegetation can improve photovoltaic energy generation efficiency by 2 to 5% in by 2 to 5%, and which is revealed by some other empirical studies. And it's particularly in this project, the research team identified 3.63% of the photovoltaic efficiency in average per year. And also based on their estimation, photovoltaic green roof can mitigate 55.9 ton of carbon dioxide, and typical photovoltaic roof can mitigate 48.22 ton of carbon dioxide respectively. And this difference of energy production is equivalent to the 110 trees planted with an additional 1.1 ton of carbon dioxide potentially mitigated by photosynthesis activity by the plants. So here's some key takeaways. For the economic benefit, the photovoltaic efficiency improvement can be very helpful for the owner of this investment as a way of making another profit. And for the environmental benefit, it will have additional carbon sequestration effect by vegetation under photovoltaic canopy, and it can increase urban biodiversity while supporting the complex food web system in an urban area, and it can also decrease surface temperature, ground surface, the building lift of surface temperature, and there may be a contribution on mitigating urban heat island effect, and it can also contribute to reducing stormwater runoff, and it can improve air quality, although it may differ depending on the types of the molecules anyway. And then it can increase the soil moisture persistence, and it can be kind of huge advantage in a very dry urban areas. And for the social benefit, there will be some educational value, and depending on the design, this photovoltaic green rooftop can be a place for the socializing for the local residents.